Hello everyone, this is lesson 4. So this lesson 4 goals is introduce the business terms, fixed cost, variable cost, marginal revenue, marginal profit, break even. So a lot of terminology and review solving linear equations and review graph of linear functions. Okay, so what is the break evens? Break evens means where cost and revenue are equal graphically. Point of intersection of the graphs of the total revenue function and the total cost function. So let me write down for you. Where cost and revenue are equal. Graphically, point of intersection of the graph of the total revenue function and the total cost function. So this means total revenue, graphically, total revenue, same as total cost function. Okay, so we have an example here. The Burnham company drivers and sells them to distributor. Burnham's total cost and total revenue in dollars for X. Thumbs drives are given by total cost 2X plus 7,920 and total revenue is 20X. How many thumbs drive must Burnham sell to break even, right? So break even, algebraically total cost equal to total cost function. So let me write down. So total cost equal to total revenue, right? So we have a total cost equal to, so total cost in that case is 2X plus 7,920, right? And total revenue, which is 20X. Now we need to solve for X, right? So that's the thumb drives. So solve for X. We subtract 2X both sides. So we have a 7,920 equal to 18X. So we divide by 18X both sides. So we have X equal to 440. Yeah, thumb drives. Okay, let me show you decimals. There's a 2X plus, let me do it here. Decimals, decimals. Graphing calculator. So we have a 2X plus 2X plus 7,920 equal to 20x okay, so probably let's do it here. When is that? And then where's the graph? Oh, it's too big, right? So one is that, one is 20x. Let me see. Oh, 2x, 20x. Yeah. So this is the point. So x equal to 440 there, right? So this point is break even. Let me screenshot. Here. Come on, screenshot. Okay, here, screenshot. This is the one. All right, so I want to explain to you this one. After this is a break even, right? So means that where total cost is same as total revenue, right? So in that case, they don't even have a profit, right? They don't even loss, right? So this is a break even. And after this point, they have a profit here. Before that, they're losing money, right? So loss money. Is it okay with you? All right, so let's do this one. DC Systems manufacturer satellite system and has a monthly profit P in dollars related to the number of satellite systems X by 4P equal to 81X minus 29,970. Find the number of a system that these systems need to produce and sell to break even. So break even, we have total cost equal to total revenue, right? So there is no losing money, there is no profit either, right? So neither losing money, nor profit, right? Okay, now in here earlier we have just the x, right? Two sides are x and x, so we solve for x, right? But in that case, we have one side is the profit p, and then other side is x as the number of a satellite, right? Okay, then how do we do in that case? Because we have a two unknown, right? So profit, because we said that total cost equal to total revenue, right? No revenue. So did I say no revenue? Total cost equal to total revenue. And that in that point, no make money, right? So we say that P equal to 0. It makes sense to you? P equal to 0. Set P equal to 0. Then left side we have 0 equal to 81x minus 29,970, right? So P equal to 0 means profit equal to 0, right? Okay, let's solve for x. So we have 29,970 equal to 81x. And we divide by 81 both sides. Then x equal to 370. So number of systems. Yeah. So if x we're selling 370, then they have a break even. And then after 370, they make money, right? That means. This number. Trophy, right? Okay. Let us do this one. Credit card debt, the interest I in dollars paid on 10,000 credit card debt over 3 years when the interest rate is R%. Percent can be approximated by equation I over 175.393 at 0.663 equal to R, right? So in the case R%, I is interest in dollars. And then they said if the credit card interest rate is 19.8%, find the amount of interest paid during 3 years. Okay, so let's do this one. So we have I, which is, we want to know, over 175.393 plus 0.663 equal to our percent. So we just using 19.8%. Okay, now okay, then we have we subtract 0.663 both sides. So we have I over 175.393 equal to 137, and we multiply by 175.393, 175.393. So I equal to, we have 175.393, which is 3,356.49. So 50. 4958, which is, we can say the 50. Yeah. Is it okay? All right, now let's do this one. We have using data from 2010 and projected to 2020. The population of a unique kingdom, Y in millions, can be approximated by the equation. where X is the number of years after 2000. So what is the projected population in 2022, right? So 2022 minus 2000 equal to 22 years, right? Okay, then we want to start for y, right? So here, 10 y minus 4.55x. So 22. So that means x. So 10.0y equal to, okay, let me calculate this one first. So we have 10.0y minus 100.1 equal to 581. So we add 100.1 both sides. So we have 10.y equal to, it's addition, right? So we have 581 plus 100.1, right? So it's a 681.1. So divided by 10 both sides. We get 68.11. So 68.11. So in what years the population predicted to be 71.75, right? So we want to solve for x, and we substitute. This is y, right? Okay, so 10 times, we have a 71.75 minus a 4.55x equal to 581. Solve for x. So we get 717.5 minus 4.505x equal to 581. And we subtract 717.5 both sides. So we get negative 4.505x equal to negative 136.5. We divide by negative 4.55 both sides. So we get x equal to 30. Okay. So since the x is number of years after 2000, so we want to add 2000 plus 30. There will be 2030 years, right? Okay. Let's do this one. What do you remember about graphs over lines? Is it linear, the lines? Lines. Like a straight line, right? So those kind of line. Straight line. Linear equation. Or we said a linear function. Okay, so we have the terms fixed cost, variable cost, marginal cost. Okay, so we have linear function. In that case, total cost, C of x, which is 10x plus $200,000, where x is the number of items produced or production level. Okay, so in that case, this is a slope, right? So we called this is a slope. So we indicate from the algebra course M, right? So slope is the 10 and has a unit. In that case, dollars per item, right? So dollars per item. Okay, let's take a look. We have a cost function here. So this is a cost function. And then this is the total cost function. Total cost. Okay, so let's take a look. When x equal to 0, we substitute x equal to 0, then we get 20,000, right? When x equal to 1, we substitute 10 times 1, and then 20,000, then 200,000, 10. And when x equal to 2, we have a times 2, so 20, then we add the 20,000, then 220, right? And so on, right? Okay, now the terminology, fixed cost, the cost of making 0 items, or the cost incurred regardless of how many units are produced. So let me write down. This means fixed cost or the expense that a business must pay even if even if it produced 0 unit. Okay, so for example, even though they don't produce anything in business, they have to pay the rent, they have to pay the salaries, right? And they have to pay the insurance, whether car or building or rent, right? Or utilities. And so on, right? Okay, now variable cost, cost that change when production level change, or cost that depends on the production level. So here, variable cost, they say that how pronounce? Raw materials, example. Raw, law, not law, raw materials, right? Or materials. So means that the cost of materials used in production. So here like direct labor, direct labor. If they produce more, then they should be they should more hire. They should more hire the employees, and they should use more electricity or gas, water, garbage, right? So utility and sales commissions. Okay, then total cost, we had the equation here. So this is the total cost, right? So total cost. So total cost combined with variable cost plus fixed cost. So here you go. Okay, we have a marginal cost, the additional cost incurred to produce one more items. So for linear cost function, marginal cost is the slope of cost function. Marginal cost. And marginal revenue, the additional revenue from selling one more items. For linear revenue function, marginal revenue is the slope of the revenue function. Marginal profit, the additional profit from selling one more item. For linear profit function, marginal profit is the slope of the profit function. So basically, marginal cost, marginal revenue, marginal profit, they want to know about the cost, revenue, profit per item. All right. Okay, so let's do this one. We have an example. Linear cost function. We have C of x equal to 5x plus 250. And find the C of 0. So C of 0 means C of 0 equal to 5 times 0 plus 250, then 250, right? Okay, what is the cost of making 0 item? So this is number of item, right? That is the x, and this is the cost, right? Okay, so what is the cost of making 0 item? So 0 item, then same as C of 0, right? So we had, that is a 250. That's the cost. Let's say the dollars, right? So same as A. What are fixed cost? So fixed cost earlier, we don't produce, right? The business don't produce any items. So but they still pay the money, right? That's the fixed cost. So there will be C of 0 as well. So C of 0, we have a 250. Okay. What is the C-intercept of the cost function? So think about y-intercept. How did we find the y-intercept from the algebra course? We said set x equal to 0, right? Okay, then graphically, how do you know y-intercept? We need to look for the point on the y-axis, right? The point on the y-axis. Okay, now let's go back to the example. What is the c-intercept of the cost function? That means we're looking at the set x equal to 0, right? Set x equal to 0. And then this means the point on the c-axis, right? So in that case, we have x-axis, c-axis, right? Which is c over x. Yeah. Okay. Then what is this? When x equal to 0, what we had earlier. So this is 0 and 250. So basically, A, B, C, D, everything's the same question, right? All right. Let me show you the decimals. C intercept. So 0 and 250, right? So let's find out decimals here. So 5x plus 250 and 0, 250 there. Okay, maybe I'm gonna copy here. That's not the one. This is the one. Okay, maybe let me make a. I hope you can see this one. All right, so find C over 50 and 51. So let's do it. C over 50, plug in, x equal to 50. So 5 times 50 plus 250. Then we get 250 plus 250, which is 500. And C of 51 equal to 5 times 51 plus 250 equal to 255 plus 250 equal to 505. 505, right? Okay. All right. Next one, by how much does the cost increase? When production increases from 50 items to 51 items. So we had from the E, we had the C over 51 equal to, let me just write down this one first, C over 51 minus C over 50, C over 51, which is 505, minus 500. So we get 5, right? So 5 production increases, right? Okay, next one. What is the additional cost of producing one more item if 100 items are being sold, right? So we want to know what's the C of 101, right? So C of 100, C of 100 equal to 5 times 100 plus 250 equal to 500 plus 250 equal to 750. And we have C of 101 equal to 500, I'm sorry, 5 times 101. 101 and plus 250. Hey. plus 250. And we get everything. So, hold on a second. 101 times 5, we get 505 plus 250, then we get 755. So the additional cost of producing one more item is also 5. So C of 101 minus C of 100 equal to 5, right? Okay, now what is the marginal cost? So we knew that marginal cost is the slope of the cost function, right? So they are same, right? So let me highlight marginal cost, same as the slope of the cost function. So in that case, we have a cost function C of x equal to 5x plus 250. What is the slope? Slope is this. That is marginal cost, right? Marginal cost. So then look, we want to know about the marginal cost means we want to know about the cost by item, right? Per item. So per item, additional item, so we get $5 in that case, if we say that dollars, right? So marginal cost, so the cost function. All right, now next one. So this is the last question, so please be patient. So cost function, we had a variable cost plus the fixed cost earlier. We call total cost function. Okay, previously we did a profit, which is equal to revenue minus cost function, right? Let's read this one. Example, extreme protection manufacturer helmets for skiing and snowboarding. The fixed cost for one model of helmet are $6,600 per month. So this is already say that fixed cost. And materials and labor for each helmet of this model are $35. So this means variable cost. This is the variable. Value of cost. Okay, so after that, we have a company sells this helmet to dealers for $60 each. This means revenue, okay? Okay, A part for this helmet, write a function for monthly total cost. Total cost, we had the fixed variable cost plus the fixed cost, right? Okay, fixed cost, we had 6,600 and variable cost 35x, yeah? So let's denote that this is a C of x. Okay, second one, write a function for total revenue. Okay, revenue we had here $60 each. So revenue function R of x equal to 60x. The third one, write and simplify the function for profit, right? So profit function, we had P of x equal to revenue minus total cost, right? So there will be revenue R of x minus C of x. So R in that case is 60x minus total cost, which is 35x plus 6600. Let's simplify. So 60x minus 35x plus 6600. That will be 25x minus 6600. So there is a P of x. Yeah. So cost, total cost, and this is a revenue. Okay, next one. Almost done. P of 400. So profit function earlier, so we have a 25, 400 minus 6600, which is 3400, and P of 401 is 25 times 401 minus 6600, which is 34,025. Okay. Next one, by how much does the profit increases when sales increase from 400 items to 401 helmets, right? So we have, what's the profit for 401 minus the profit of 400, right? So that would be, we just had from the previously, 3,425 minus 3,400, which is 25. Okay. F, what is the additional profit of selling one more helmet if 642 helmets are being sold? So similar with the previous one. So we have, what's the profit of 643 minus profit function of 642, right? 642, then 25, 643 minus 600 minus 25, 642 minus 606. Okay, so there will be 9,475 minus 9,450, which is 25 as well. So same as earlier. Earlier we had 5 and 5. Here 25, 25, right? Last one. What is the marginal revenue profit? What is the slope of a profit function? So same, right? Marginal profit means the same as the slope of a profit function. So in that case, we had 25, right? Because profit function is, let me write down G. So this is the one, right? Copy. So this is a profit function. So marginal profit 25 means that for each additional unit sold, each additional helmet in this case, profit increased by 25, right? So marginal profit. Marginal profit, same as the slope of the profit function, which is slope, yeah, which is 25. Okay, all right. Thank you for watching. See you. Bye-bye.